Hello, my name is Haodong Feng from the Xianjiao Liverpool University, and I'm also a master student of the University of Liverpool. At present, I hope to present my survey paper, Optimal Control and Reinforcement Learning for Robots, a survey. In my following presentation, I'll introduce the abstract and overview of this survey paper. Then is the introduction and optimal control problem statement. After that, I'll present several solutions of optimal control for the robot. And then I'll introduce several future research prospects, directions, and discussions the development of the optimal control for robots. After that, it's the summary and conclusions. Finally, it's the acknowledgement of this paper. The development of reinforcement learning and optimal control has become an impetus of engineering, which has shown large potentials on automation. Currently, the optimization applications on robots are facing challenges caused by model bias, high-dimensional systems, and computational complexity. To solve these issues, several researchers proposed available data-driven optimization approaches. This survey aims to review the achievements on optimal control and reinforcement learning approaches for the robots. This is not a complete and exhaustive survey, but provides some latest and remarkable achievements for the optimal control for robots. It introduces the background and facing problem statement at the beginning. The development of the solutions to existing issues for robot control, and some notable control methods in these areas are reviewed briefly. In addition, the survey discusses the future development prospects from 4 aspects, as research direction to achieve improving the efficiency of control, the artificial assisted learning, the applications in extreme special environments, and the other related subjects in the engineering developments. The interdisciplinary researches are essential for the engineering fields based on optimal control methods according to the perspective, which wouldn't only promote engineering equipment to be more intelligent, but extend the applications of optimal control approaches. The optimal control is to make the performance index achieve optimal state, which can find an optimal kind to achieve predetermined destination. Currently, the well-utilized data-driven optimization algorithms of robot control are developed according to the reinforcement learning, which is known as a goal-oriented learning method. There are 3 issues on robot control. Firstly, the purpose of optimal control, which is to achieve the optimal performance. It's the major limitations of it. Many researchers focus on the precision and efficiency of control. The second one is the capacity of computation, which limits the algorithm application. The real-time model-free reinforcement learning requires a large amount of computation and strong processors, so that it's hard to be employed on real-time robots. Finally, the preceding model bias while model learning is also a problem, which is emphasized by many researchers who attempt to reduce the model bias by policy optimization. The main objective of this paper is to investigate the advantages and disadvantages of optimal control and reinforcement learning approaches. for the robots based on our understanding of present and recent advanced automatic techniques in the references. This paper can be applied to get the design of efficient controllers from the data-driven learning aspects for the automatic robots. The rest of this paper is organized as follows. The section 2 presents the general statement of optimal control problems formations. The section 3 reviews the previous published solutions facing for robot optimal control design regarding the improvement of precision and system complexity, the reduction of model bias, and the decrease of computation. The section 4 discusses the future research's directions to improve the performance of robot optimal control applications, and the interdisciplinary development among optimal control and other engineering areas. Different from the previous published related reviews. In section 5, the main conclusions and contributions are described. The optimal control problem has several fixed formations. The optimal algorithms aim to solve the constraint optimization problem with cost function like said in this survey. You can see my survey and the detailed descriptions can be found in the survey paper. Several successful stories presented available solutions for problems caused by the model bias, complex system, and large computation, which are developed of optimal control. The first one is improve precision and system complexity. The second one is overcome model bias. The third one is reducing the computation. For improving precision and system complexity, the degree of freedom is often an essential factor which influences the performance of robots. It's hard to model and control a high-dimensional robot whose system is much more complex. The first bibliography used model-based deep reinforcement learning method to represent the model-free reinforcement learning to reduce the value test sample. It utilized a medium-sized deep neural network which was trained by gradient descent to learn the system of model. Then, the MPC method is employed to complete the task. For overcoming the model bias, and solutions in which are used to improve precision of controllers. Several algorithms were proposed to overcome model bias of the nonlinear systems. There are two research directions on solving this problem. By using an advanced and efficient model learning approach, more exact model can be trained and learned, where the deep neural network or the linear Gaussian method. Another approach is to employ the precision policy iteration algorithms, which can optimize strategies according to interaction with the environment at each iteration. Finally, for reducing the competition is an essential factor when implement algorithms in robot equipment, caused by limitations of processor. And model-free reinforcement learning approaches need much more computation as high-performance computer, which face limitations on real-time robots. The first reference proposed an adaptive movement estimation approach, which is an effective random optimization method requires little memory and first-order gradients. is computational efficient and had little memory requirements. Although the approaches in optimal control and model-based reinforcement learning are facing the aforementioned issues, the development is still prosperous as the prospect is bright, and the applications are very essential and wide. Various methods are proposed to overcome these numerous problems and adapt to different application scenarios. Some surveys about reinforcement learning-based robotics were reviewed by previous published works. According to these surveys, this paper discussed 4 directions which can be followed in the development of optimal control at present. There are 4 research directions can be found in this survey paper. Now, I expect to take the application in deep ocean technology as an example. The autonomous underwater vehicle is an underwater robot widely used in the deep sea technology for the autonomous underwater control without cables. It has its own energy and relies on its own autonomy to manage and control itself to complete the work and exploration in the deep ocean environment. The reinforcement learning can optimize the system performance through continuous interaction with the environment. MBI and the reinforcement learning has strong adaptability to the environment. Thus, the applications of this type of algorithms on the AUV to improve the adaptive ability for the path planning, speed control, obstacle avoidance abilities, which can improve the autonomy, perception, and even survival rate, as the real underwater environment is always complex, harsh, and even dangerous. For the summary of this survey describes the development and applications of the previous optimal control algorithms on robot technology, and the comparison and analysis of different kinds of control approaches using for the automatic robots. In addition, 3 main problems of today's algorithms are discussed, and several successful stories are reviewed to solve these kinds of problems. The survey discusses the future prospective directions of optimal control and model-based reinforcement learning, which include overcoming limitations, artificial assistance learning, applications in complex and special extremely environments, and the interdisciplinary developments in the other data-driven optimization fields. Through this survey, the following conclusions can be drawn. Researchers will pay more attention on the reduction of model bias and the improvement of the optimization efficiency. A more precise modeling method and more efficient control algorithm with little computational complexity will be developed for the high-dimensional robot systems. The optimal control approaches will be used in the other areas controlled widely, and their applications will make the systems achieve the optimal solution and have better performance. The applications on complex and extreme environment robots will help to carry out researches in extreme environments regarding the deep ocean, such as the ROV and the AUV applications, and the space for the neutral science exploration. And Finally, the artificial assisted learning applications for industrial robots are available ways to apply the advanced optimal control algorithms in the industrial practices. This work was supported by the Research Development Fund RDF 200108 provided by Xi'an Liu University. That's all my presentation. Thanks for listening. And if you have any questions, you can submit email and discuss in the forum during the conference. Thank you.